than the older ones. So these two segments of the database is independent. But the paired sample is not independent because the same respondents answered the question that how they perceive the healthiness, and the same respondents answer the question that how they perceive the trendiness of the brand. So we compare the same people's two different opinions to each other in this case, but in the previous case, in case of ANOVA, we compared two different groups' opinion about the same thing. So we change the matrix. So in this case, in the paired sample t-test, we compare the same opinion, the same people, two different opinions, the perception of the healthiness and the perception of the trendiness. And in case of ANOVA, or independent sample t-test, we compare the same phenomena in case of two independent segments of the database. Okay, click on the paired sample t-test. Paired samples t-test. And you should select two variables you want to compare. And this case is the perception of the healthiness of the brand 1A. Sorry, not the healthiness, sorry. The taste and the trendiness. So the question is again that how they perceive the trendiness, taste and the trendiness of this brand is different or not, or they perceive the same level of performance in case of these two attributes. So you can click on the options and you can set the confidence level, how confidently you want to say, conclude that they perceive it in a different way or not. It's typical that 95%, that's the confidence level. So you shouldn't change anything, just click on OK. We have three tables. We have these descriptive statistics we had before in case of the descriptive statistics we run before. So you can see the average values, the mean 3.08, 3.22. You can see a correlation which is not asked for. So here is some correlation between the two variables. We were not interested in the correlation. That was not the research question. The third table answer a research question. Do they perceive differently or not the opinion of the consumers about these two attributes? You can see that the mean difference between the mean values is 0.14. There is some standard deviation as well. There is a t-test, which is the f-test in ANOVA. That's the test statistic. There is a degree of freedom as well. And you can see, again, a probability which is automatically the same rule we can apply. If it's below 5%, we can say that this true mean is different. If it's not below 5%, this true mean is not different statistically. They're not significantly different. That is, we cannot be sure that in the population they are different as well. So we can conclude that we couldn't diffuse this null, have to then, etc. So the